Section 8.2, Solving Inequalities Using Addition or Subtraction, Part 1.
Alright, so we're going to move into 8.2 now. And now that we know how to write inequalities and translate them from proper English sentence into mathematical sentences, and we know how to graph these on a number line, we're going to move on to actually computing with inequalities. So this is actually solving inequalities, so now we're going to have a process to isolate the variable by using addition and subtraction. We're going to start with just addition and subtraction just like you did in elementary school. So we have another property in math. We have so many rules based on different aspects of math. These are the rules that follow inequality. So we have the addition property of inequality. So instead of the addition property of equality, that's what we use for equations, this is the addition property of inequality. This is the property we use to solve inequalities. So in words, you can add the same number to each side of the inequality, and the inequality will still remain true. That's a fact in math. So I'm going to show you how it works. So if you have a true statement with numbers that -3 is less than 2, it's a true statement. They're saying with the addition property of inequality, I can add a number to both sides of that inequality, and the inequality will still remain true. So let's just pick a random number. Let's pick 5. If I add 5 to both sides of the inequality should remain true. -3 plus 5 is 2, is less than 2 plus 5, 7. Is 2 still less than 7? And yes, it is. So that's where they came up with the addition property of equality. You're allowed to add a number to both sides of a true statement and it will stay true. So taking the idea from numbers into the algebraic world, now all of a sudden we have a variable on this side. So we have some number, x minus 3, is less than -10. So now I'm going to have to perform an operation on both sides of the inequality to isolate the variable. And we look for inverse operations. So if x is being subtracted by 3, to invert that, we add by 3. So we're going to add 3 to both sides of the inequality, just like we do for equations. But instead of an equal between, we're not keeping the equations balanced, we're comparing them. We're keeping the left side greater than the right side. We have to keep it true. So in this case, inverse operations produce a 0, and x plus 0 is x, is less than, we keep the sign, -10 plus 3 is -7. So now I know where all my solutions are. The difference between an equation and an inequality is that an equation has a single solution. An inequality has an infinite amount of solutions. So we say the solutions are. So in this case, to make this inequality true, the solutions for x are all less than -7. So if we have to graph that, we would graph that on a number line. We would have -7 and then a region to the right of -7 and a region to the left of -7. So I can see both sides. And then it would be an open circle because -7 is not a solution, so we're not including it. And this is x is less, so all my solutions are less. So I would draw my arrow to the right and shade everything to the right, to the left of -7. So again, x is less than -7. So then, taking the idea of addition, can we then expand that into subtraction and hopefully say, okay, I can see where this is going. So in words, if you subtract the same number to each side of the inequality will remain true. That's a fact in math. So let's test that fact. So I gave you a true statement, -3 is less than 1. Now let's subtract 7 from both sides. Okay, just a random number. What I do to one side of the inequality, I must do to the other. So I'm going to subtract the same number, and on the left I get -10 is less than, and on the right I get -6. Is that a true statement that -10 is less than -6? It is. Therefore, we can follow through with the fact that the subtraction property of inequality is based in truth. So now we're going to extend that from numbers into algebraic world, into our equations, and inverse operation of addition is subtraction. So I'm going to subtract 7 from the left and the right side of the inequality. +7 and -7 make a 0, leaving me a single x. Keep the sign. X is greater than or equal to. Now I have -20 minus 7 more, which is -27. So all the solutions that will make this original inequality true are all greater than or equal to -27. Quick graph on that one. Show -27. Show me some numbers to the right, show me some numbers to the left, show me both regions, put a circle on the boundary point. Is the boundary point included? It is because of that bar, so I'm shading in the boundary point because negative 27 is part of my solution set, and x is greater, so I need all the numbers greater than that in my solution set, so I shade to the right. So that's a quick refresher of graphing and our two properties, addition property of inequality and subtraction property of inequality. We're going to use these now throughout the notes so that we can learn how to add and subtract using inequalities.
Proceed to part 2.